Picture this. You're deep in building a login feature for your app. You've got 15 modified files, a bunch of uncommitted changes, and you're finally in the zone. Then your manager messages you, production is down, we need a hotfix right now. So you scramble, git stash, git checkout main, git checkout p hotfix, fix the bug, commit, push, git checkout back to your feature branch, git stash pop, pray that nothing conflicts. 7 steps. Your mental state is gone, your flow is broken, and half the time the stash pop gives you merge conflicts anyway. What if I told you there's a way to just open a separate folder, fix the bug there, and come back to your feature branch exactly as you left it? No stashing, no switching, no conflicts. It's called Git Worktree. And once you learn it, you'll wonder how you ever lived without it. Let me show you the problem using a real example. Imagine you're building TaskFlow, a team task management app. You're on a feature branch called Add Notifications. You've modified the API routes, the email service, the notification component, the database schema, and a bunch of tests. 15 files changed, 2 hours of work, uncommitted because you're not done yet. Now your teammate finds a critical bug. The task assignment endpoint is returning 500 errors in production. Users can't assign tasks. You need to fix this immediately. Here's what you have to do without worktrees. Step 1, git stash to save your uncommitted work. Step 2, git checkout main to get back to the stable branch. Step 3, git pull to get the latest production code. Step 4, git checkout b hotfix assignment to create the fix branch. Step 5, find and fix the bug, commit and push. Step 6, git checkout add notifications to get back to your feature. Step 7, git stash pop to restore your work. That's 7 steps with multiple context switches. And here's what can go wrong. Your stash might conflict with changes that happened on main while you were working. You might forget you have something stashed and lose it. If the hotfix takes a while, you might stash multiple things and lose track. Your IDE has to re-index everything twice. Your node modules or build cache might get invalidated. It's a mess. And every developer goes through this multiple times a week. So what is Git Worktree? Think of it this way. Normally when you clone a repository, you get one folder with one branch checked out. That's your working tree. You can only look at one branch at a time, and switching branches means changing all the files in that folder. Git Worktree lets you create additional working directories, each checked out to a different branch, all connected to the same repository. Here's a simple analogy. Imagine your code base is a book. Without worktrees, you can only have one bookmark. If you want to read chapter 5, you lose your place in chapter 2. With worktrees, you can have multiple copies of the book open at different chapters simultaneously. But here's the clever part. They all share the same table of contents and the same page content underneath. It's not like cloning the whole book for each bookmark. The key technical detail is that all worktrees share the same .git directory, which means they share the same commit history, the same branches, the same remote connections, and the same object database. This means creating a new worktree uses almost no extra disk space. It just creates a new folder with the files checked out at the right branch. Let me walk you through the actual commands using TaskFlow. You're in your main repository folder working on the notifications feature. That hotfix comes in. Instead of stashing and switching, you run one command, git worktree add /taskflow hotfix main. That's it. Git creates a new folder called TaskFlow hotfix right next to your main folder, checks out the main branch there, and you're ready to go. Your original folder is completely untouched. You cd into the hotfix folder, create the fix branch, fix the bug, commit, push, create the PR. When you're done, you cd back to your original folder. Everything is exactly as you left it. Then you clean up with git worktree remove. Let me show you the 4 essential commands. First, git worktree add, which creates a new working directory. You give it a path and optionally a branch name. If you add the B flag, it creates a new branch at the same time. Second, git worktree list, which shows you all your active worktrees, what branches they're on, and what commits they're at. Third, git worktree remove, which deletes a worktree when you're done with it. And fourth, git worktree prune, which cleans up any stale references if you ever manually delete a worktree folder instead of using the remove command. That's really all you need to know. 4 commands. Let me put the before and after side by side so you can really see the difference. Without worktrees, The hotfix workflow is 7 steps: git stash, git checkout main, git pull, git checkout, b hotfix, fix and commit, git checkout feature, git stash pop. You're touching your working directory 3 times. You risk stash conflicts. Your IDE reindexes everything twice. Your node modules might need reinstalling. Your mental context is completely shattered. With worktrees, it's 3 steps. Git worktree add to create the hotfix directory. cd there, fix the bug, commit, push, cd back to your feature directory. Done. Your feature branch directory was never touched. No stashing, no switching, no conflicts, no reindexing. Your terminal in the feature directory still shows the same files, the same git status, the same uncommitted changes. Now, let me compare worktrees to the other alternatives. Git stash is fine for quick, small context switches, but it's risky for anything longer than a few minutes. Git clone creates a completely separate copy of the entire repository. It works, but it doubles your disk space, has separate remotes, and the histories are independent. Git Worktree is the sweet spot. Minimal disk usage because it shares the object database, shared history and remotes, instant creation, and complete isolation between working directories. Now let me give you real use cases beyond just hotfixes. Use case 1. Reviewing a pull request while you're mid-feature. Your teammate asked you to review their PR. Instead of stashing your work or cloning the whole repo, you create a work tree for their branch. Git worktree add /TaskFlow review, add payments, open it in your IDE, read the code, run the tests, leave your comments, then remove the work tree. Your feature work was never interrupted. Use case 2, running tests on one branch while coding on another. You've got a test suite that takes 20 minutes. You don't want to sit and wait. Create a work tree, start the tests there in one terminal, and keep coding in your original directory in another terminal. Both running simultaneously, zero interference. Use case 3, comparing behavior across versions side by side. You need to see how the app behaves in version 1 versus version 2. Create work trees for both release branches. Start each one on a different port. Open both in your browser and compare them side by side. Use case 4, the advanced bare repo pattern. Instead of having one main directory with work trees as extras, some developers clone as a bare repository and create work trees for everything, including main. This gives you the cleanest directory structure where every branch is its own folder at the same level. No branch is special. This is especially popular with people who work on many branches simultaneously. Let me walk you through a complete hands-on example with TaskFlow. Start in your terminal. First, make sure you have Git 2.5 or higher. Run git -- version to check. Now let's say TaskFlow is cloned at home/project/TaskFlow. You're on main. Let's create a feature worktree. Run git worktree add /TaskFlow feature b feature login. This creates a new folder called TaskFlow feature next to your main folder with a new branch called feature login. Verify it with Git worktree list. You'll see both directories listed with their branches. Now cd into TaskFlow feature. Important, run npm install here because each worktree has its own node _ modules. The source code is there, but dependencies need installing. Start coding your feature, edit files, add new files, whatever you need. Meanwhile, back in the original TaskFlow directory, everything is still on main, untouched. When you need to switch context, just cd between the two directories. No git commands needed. When your feature is merged and you're done, go back to the main directory and run git worktree remove /TaskFlow feature. Clean and simple. One key rule: you cannot have the same branch checked out in 2 work trees at the same time. Git prevents this to avoid confusion. If you try, it'll tell you that branch is already checked out somewhere else. This is actually a safety feature, not a limitation. Now here's where it gets really exciting. This is the reason this topic went viral this week. Boris Cherny, an engineer on the Claude Code team at Anthropic, showed that Claude Code now has built-in Git Worktree support, and it changes everything about how AI coding assistants work. Here's the problem. When you run an AI coding agent, it reads and writes files in your repository. If you want multiple AI agents working on different tasks at the same time, they'll overwrite each other's changes. Agent 1 modifies the API file. Agent 2 modifies the same file. Chaos. The solution? Give each agent its own worktree. In Claude Code, you can run Claude-worktree feature auth in one terminal and Claude-worktree bug fix payments in another terminal. Each agent gets its own isolated directory with its own branch. They share the same repository history but can't interfere with each other. When they finish, you have two separate branches with clean changes that you can review and merge independently. Think about what this means. Instead of working on one task at a time, you can have 3, 4, 5 AI agents working in parallel. One is building a new feature, another is fixing a bug, a third is writing tests, a fourth is refactoring old code, all simultaneously, all isolated, all reviewable separately. Git Worktrees provide the isolation layer that makes multi-agent AI coding possible. Without Worktrees, you'd need multiple full clones, wasting disk space and losing shared history. Worktrees solve this elegantly. This isn't just about Claude Code either. You can use this pattern with any AI coding tool. Open each worktree as a separate project and run your AI assistant there. Cursor, Copilot, Aider, any of them. Before you start using worktrees, here are 5 gotchas you should know about. Gotcha 1. You cannot check out the same branch in 2 worktrees. If you try, Git blocks you with an error. This is by design. The workaround is to create a new branch from the same commit if you really need it. Gotcha 2. Never manually delete a worktree folder with rm/rf. Always use Git Worktree remove. If you do delete it manually, Git still thinks the branch is checked out there. Run Git Worktree prune to clean up the stale reference. Gotcha 3. Each worktree needs its own dependencies. A new worktree has the source code but not your node modules, not your Python virtual environment, not your build cache. You need to run npm install or pip install or whatever your setup command is in each new worktree. Gotcha 4. IDE support. Open each worktree as a separate project or workspace. Don't try to open multiple worktrees in one IDE window. VS Code, JetBrains, and Vim all work great with worktrees as long as you open them as separate projects. Gotcha 5. Submodules. If your project uses GT submodules, worktrees and submodules don't play well together yet. The Git documentation explicitly warns against this combination. If you use submodules, test carefully before relying on worktrees. Here's how to get started right now. First, check your Git version. Run git -- version. You need 2.5 or higher and anything recent will have it. Second, next time you need to context switch instead of stashing, try Git Worktree add. Create a worktree for the other branch and just cd there. Keep it simple. Third, after you're comfortable with the basics, try the bare repo pattern for a project where you work on many branches. Clone as bare, then create worktrees for each branch. It's the cleanest way to organize. And if you're using AI coding tools, especially Claude Code, try the worktree flag. Having multiple agents work in parallel on isolated branches is a game changer. The Git Worktree command has been around since 2015, but most developers have never heard of it. Now you know it, and you know why it just went viral. If this video helped you understand Git Worktrees, subscribe for more developer concepts explained simply. See you in the next one.